So in this lesson, we'll be diving into the arithmetic sequence, and I'll be going through 3 questions that really highlight the frameworks of how arithmetic sequences are asked in the exam and addresses really the main pain points and misconceptions associated with arithmetic sequences. So this first question, we're given that the arithmetic sequence is given by -1, 1, 3, and 5, and we're told that this is an arithmetic sequence. So automatically we know that the general term of the arithmetic sequence given by Tn equals to a plus n minus 1 times d, and a being the first term and d being the common difference. So means that somewhere along the line, if we ask to find the nth term of the general term, this is the formula we'll be really referencing, where a is the first term, d is the common difference. So the first question says determine the fifth term of the sequence. The fifth term of the sequence, which is T5, really. So let's just rewrite our pattern here. And to determine the fifth term, we need to construct our tree line of differences, meaning that we say T2 minus T1, which would be 1 minus 1. In essence, it will give us 2. Then we'll say 3 minus 1, which will give us 2, and 5 minus 3, which will give us 2. So therefore, if this pattern continues the same way, you can see that what's happening, they're adding 2 to the previous term. It means that if you add 2 to 5, you're going to get 7. So we can safely say that term number 5 is equals to 7. And we would have answered the first part of the question, or we would have answered A, number 1. So if we go to number 2, question number 2 is asked us to determine the nth term of the sequence. So the nth term of the sequence is really the general term Ta. Tn is equals to a plus n minus 1 times d. So from the above, we saw that our a, our first term, was -1, and d, the common difference, was 2. So we just substitute all those values in there. Tn is equals to a is minus 1 plus n minus 1 times d, which is 2. Really, I always advise that you further simplify this formula so that it's easier and quicker when you really substituting values into it. So what we're going to do, we're going to just multiply 2 into n minus 1, then we're going to get plus 2n minus 2, which can then be simplified as 2n minus 3, and we would have really gotten our Tn, and there's nothing wrong if you leave it as that. I really prefer it in this form because it's easier to substitute in that regard. So we can move on to the next question, which is number 3. It asks us to calculate another term. So number 3 is asking us to calculate T53, which means we need to find what term number 53 is. So remember, we have our general formula, or nth term. So we're just going to say T53. We're going to substitute 53 where there's n, and we're going to calculate what T53 is. If we calculate 2 times 53 minus 1, you get 103. And we would have answered question number 3, and we've done question number 2. So that's the answer for question number 3. And we move on to question number 4. Question number 4 is asking us to determine the term, and the keyword is term here. Term is nothing more than n, really, the term that's equals to 97, right? Means that from our general term, we have our general term to be Tn is equals to 2n minus 3, but they're asking us for a term that's equals to 97. So really we just substitute 97 as tn, and tn minus 1, and really what we're looking for is our n, because n represents term. This is our term, and this is our value, right? If you substitute whatever term number you want, term 2, you get what value it is. So here they gave us the value that it's equals to 97. We need to calculate what the term is, which is n. So we need to isolate 2n. We can take the 3 to the other side of the equation. We'll have 97 plus 3 equals to 2n, and 2n really 97 plus 3 is 100. Divide both sides by 2, then n is equals to 50. It means that what this simply means is that if you substitute n in the general term, you get the value of 97. So then we would have answered our questions. So this is just really the basics of really arithmetic sequences, where you're asked to find the nth term, certain term number, and what term value is equals to. So question number really, I would say question number 3, and question number 4 really are questions that you really have to look close to, because it's where a lot of learners miss a lot of marks, more especially when they're given the term, example of the 97, and they're unable to know when they're given the term value how to find n. And this is one of the ways to do it. So let's move on to another question to build up from this, where we're given a question with unknowns. So we're given an arithmetic sequence, and in this arithmetic sequence really we're given that you have x plus 3, 2x minus 2, 5x plus 1. And you can see that now you're dealing with really unknown variables of x, but you're told that it's an arithmetic sequence, so it still has the same properties. We know that the general term will be tn equals to a n minus 1 times d, where a is the first term, d is the common difference. It still applies here, even though it looks a little bit different. So let's go and attempt the first question, which says determine the value of x. So we need to calculate what the value of x is using what we know, or what the properties of an arithmetic sequence are. What we know that when you give an arithmetic sequence, you need to always construct a tree line of differences. We're saying term number 2 minus term number 1, which is 2x minus 2 minus x plus 3, and I'm putting it in brackets just to make it neat. And I'm going to say 5x plus 1 minus 2x minus 2. And we can further simplify this to be 2x minus 2. We multiply in the negative, we get negative x, negative 3. Then we have a common factor, 2x minus x, x minus 2 minus 3, minus 5. So that will be a common difference. And we simplify this as well, 5 plus 1 multiplied by negative. We have negative 2x plus 2. And then we'll have 5x minus 2 is nothing more than 3x. And then 1 plus 2 is 3. So an important property that we have to remember of arithmetic sequences is that the common difference, meaning that the differences will be equal. So we can safely equate these differences. Once we equate the differences, what's going to happen is that we'll be able to solve for x, because now x will be unknown. So we simply equate the differences. X minus 5 is equals to 3x plus 3. Then we solve for x. We group the like terms, x and x. We can take the 3x to the left hand side. We'll have x minus 3x equals to, take the 5 to the right hand side. We have 5 plus 3. Then we have minus 2x is equals to 8. Then we divide both sides by negative 2. We have x is equals to negative 4. So our x value is equals to negative And by that, we have answered the first question. And really, we broke down this intimidating question by just knowing and acknowledging the properties of an arithmetic sequence, that the common differences are equal, and we solved for x. So the next question is asking us to calculate the first three terms. Now we determine the first three terms of the sequence. So calculate the first three terms of the sequence will be very simple. What we do is, since we know that x is equal to -4, it means where there's x, we're going to substitute -4. -4 is 3, 2 by -4 minus 2, 5 by -4 plus 1, -4 plus 3 minus 1, 2 times -4, minus 8 minus 2, minus 10, 2 by -4 is -20, -20 plus 1 is -19. So these will be the first three terms of the sequence. We achieved them by just substituting the values of x that we calculated in the previous question. So we would have answered the second question. When we move on to the third question, where it's asking us to determine the 20th term of the sequence. So to determine the 20th term of the sequence, we have to really calculate our general term. To calculate the general term, remember we're given the sequence, or we just really discover that our sequence is -1, -10, and -19. What we need to do now is construct our tree line of differences to determine our common difference. So we're going to say -10 minus -1. So it will be -10 minus -1, and -19 minus -10. And let's move our working so we're able to have more room in space. So we can just shake this working, bring it to the top. So let's rewrite our pattern to be -1, -10, -19, and second term minus the first term is -10, minus -1. Third term minus the second term is 19, minus -10, really, which is equals to -10 minus -1 is the same as saying -10 plus 1, which will give us -9. -19 minus -10, same as saying -19 plus 10, which will give us -9. So we know that our D, our common difference, is equal to -9. Our A, first term, is equal to -1. Therefore, our general term Tn is equal to our A value is -1. It's n minus 1 times our D, -9, and we simplify this. Or we can just really answer the question by saying what's the 20th term. Remember, looking for the 20th term. We can really just substitute what 20 will be. It should be -1 plus 20 minus 1 times -1. And then we'll calculate what T20 is. Yes, substitute in calculator -1 plus 20 minus 1 times -9. Then you'll see that you get -172. And that will be our answer for T20. Then we would have answered the third question. And let's go and tackle the fourth question. So in the fourth question, we're told that which term in the sequence, and again, that term is coming up again, which term, they're asking us for the term, which term in the sequence will be equals to -4. So which term, it means you're looking for n. So let's go and plug everything into the equation. So we know that our general term is equal to negative 1 plus n minus 1 times minus 9. Let's quickly really make this equation very simple. So we're just going to multiply everything by negative 9. We're going to get negative 9n plus 9. Therefore tn is nothing more than negative 1 plus 9 will give us 8 minus 9n. So this is our general term simplified. So we're finding term n that's equal to negative 64. So this term is equal to negative 64. So we substitute it there and then we calculate what n is. So it will be negative 64 minus 8 or equals to negative 9. So you say negative 64 minus 8, then you'll get negative 72. And you divide both sides by negative 9. Let's see what answer you get. And you get that 8. N is equals to 8. And you would have answered the question and gotten 4 marks. And this is really just a schematic of how really they pair the questions in a scaffolded way, which means they increase the level of intensity from question 1, 2, 3, and 4. And let's go to another question on arithmetic sequences, which really involves two topics in maths, which is arithmetic sequences and also simultaneous equations. So we're given that the arithmetic sequence T4, term number 4 is equals to 40, and term number 20 is equals to 94. So the first question we asked to determine the general term of the sequence. Second question we asked to determine the 240th term. So how do you go about answering this question? Pretty simple, straightforward. Remember the general term of an arithmetic sequence, we always go back to the fundamentals. It's n minus 1 times d. So we are told that T4 is equals to a n minus 1 from our knowledge. But remember, n for T4 will be 4. So with this n, we can just simply substitute 4. And we are told that T4 is equal to 14, meaning where there's T4, we're going to write 14. Just a plus 4 minus 1 is 3 times 3. Will give us 3d. So you can see we generated an equation. So we do the same thing for T20, where we say T20 just a plus the n for T20 is 20 minus 1 times d. And then we're told that T20 is equal to 94. You just substitute 94 is equals to a plus 20 minus 1 times d is 19d. So you can see that really we have two equations, and we can easily label our equations if you wish. Equation 1 and equation 2. So there's two ways of solving these equations, either by substitution or elimination. So what I like to do really is to write these equations side by side so as to see which method you can use. It's a plus 19b, or I'll just write them one on top of the other. So this is our equation 2. So what you can see is that the easiest way here, we can just really use the method of elimination. And how do you use the method of elimination? We just substitute really, or subtract the two equations. We can say equation number 2 minus equation number 1, and that we're going to say equation number 2 minus the equation top. So we're going to be minusing these two equations, and obviously we'll be saying the bigger number minus the smaller number. So in this case it will be 94 minus 14, and we'll write down the answer that we get, which will be 80, equals to a minus a will be 0, and 19 minus d give us 16d. So we can see that we eliminated a by using that method. So what we have is 16d is equals to 80. So what we can do is just divide both sides by 16 to get the value of d. So therefore d will be equals to 5. So once we found the value really of d, we can just substitute the value of d on either equation. Either we substitute it in equation 1 or equation 2, whichever equation really looks less intimidating and looks easy. So for simplicity, we'll just substitute it on the one that looks far much easier. In this case, it will be equation 1. So I'll go ahead and use equation 1, which is 14 is equals to a plus 3 times our d value is 5. It should be 14 is equals to a, 3 times 5, it's 15. So therefore, take the 15 to the other side of the equation. Therefore, our a will be equal to 14 minus 15, nothing more than minus 1. So the question didn't say find a or b, it says you must find a general term. So let's write our answer in general term, in the form of a general term, meaning that we have to write our answer in this format there. So Tn equals to our a value is minus 1, it's n minus 1 times our d is 5, and I can either leave it as this or go ahead and simplify it to be minus 1 plus 5n plus 5, and therefore our Tn will be equals to 5n minus 6, and then really we would have answered the first part of the question. And to move on to the second part is asking us to calculate what the 240th term is, meaning that we just need to calculate what T240 is. So that's simple, we just substitute it into our really general term there. Means where there's n, we substitute 240 minus 6. Therefore term 240 will be equals to 5 times 240 minus 6, which will give us 1194. And we would have really cracked this question. We would have answered the first question and really the second question. And that's just a summary of arithmetic sequences using different types of questions that examiners might throw at you.